In this example, we're given a state of plane stress. We know sigma x, sigma y, and tau xy. Based on those numbers, we're asked to find what the maximum in-plane shear stress is, the principal stresses, and base all that on drawing the Mohr circle. The numbers that we need to draw the Mohr circle include the average normal stress between sigma x and sigma y. So that's sigma x plus sigma y divided by 2. So that's a plus 48 for sigma x, a minus 32 for sigma y. So the average value then ends up being 8 megapascals. The radius of Mohr circle, r, we know that that's given by sigma x minus sigma y divided by 2 squared plus tau xy squared. So this is 48 plus 32 divided by 2 quantity squared. Tau xy, that's 16. That radius is 43.08 megapascals. Okay, so that's what we need for that. We know from our equations that sigma 1, the largest principal stress, is sigma average plus the radius of Mohr circle r. That ends up being 51.08 megapascals. The other principal stress, sigma average minus r, that number is minus 35.08 megapascals. And the in-plane maximum shear stress, tau max in plane, is equal to r. That's 43.08 megapascals. Okay, so let's draw our Mohr circle. We know that the center is there at 8. The far extreme of our Mohr circle, that's going to be over there at 51. So if I tick off some marks here, 8, 16, 24, 32, 40, so somewhere around there, I'm going to have a Mohr circle, again centered at 8 and roughly of this size here. The important thing is that we have the center there at 8. So the center here is at sigma average, which is 8. The largest principal stress, sigma 1, 51.08 megapascals. The smaller of the two principal stresses, sigma 2, is minus 35.08. And the tau max in plane is equal to 43.08. I guess to be complete, let's go on and draw in the x-axis. We know the x-axis on the x face, we have a normal stress of positive 48, and we have a shear stress, which is positive, in this case from my plot down, of 16. So I go over to roughly 48 to the right and 16 down, so somewhere around here. It's going to be the x-axis. So if we want to know through which angle we need to rotate our stress element to reach sigma 1, that's twice the angle there. So you can do the math, you can do the trig here to find out what that angle is, and that's the angle through which you'll need to rotate that in order to hit that first principal stress there of sigma 1. So here this is just a very straightforward application of using our Mohr circle equations. Those are the average stress, which defines the center. The radius is defined by r. And from that we have some very basic equations for sigma 1, sigma 2, and the maximum in-plane shear stress there of tau.